let's welcome our first speaker, Mr. Suneet Gupta. Suneet Gupta is a civil engineer with a postgraduate in business management. He is a concrete technologist, having more than 25 years of experience in the field of cement and concrete. He has been closely associated with various cement and concrete companies pan India. Mr. Gupta has conducted various workshops and practical training sessions on various aspects of cement, concrete, and construction. He has been awarded as Personality in the Field of Concrete for the year 2007 by ICI-NDC. Mr. Gupta will speak on Towards Sustainable Concrete. So let's welcome Mr. Suneet Gupta.
Talk about this sustainable concrete, the materials. I'll speak about the materials, their sustainability, how we should, sustain them for our future generations. Coming to that, I'll start with the cement. If you see an overview, the cement production today is 4.25 billion tons per annum worldwide, out of which 2.1 is contributed only by China, whereas we in India are, at 370 million tons per annum. Whereas as far as the consumption goes, we are still way below than the average consumption per capita with the world. Forget about China. China is way too ahead with 1,800 million ton, 1,800 million metric tons per capita. So still there is a lot of scope for the consumption to be increased in India as far as India goes. And looking into our infrastructure development these days and the future vision of our respected Prime Minister, we do see an increase in this per capita consumption very shortly to a greater height. Now, when we talk about sustainability of raw materials which are used for making concrete and hence in the construction, all the raw materials what we see are coming from our Mother Earth, what we call it as a natural resources. Obviously, the quantity is restricted. It may last as per the consumption, what we see or what we do. Quantity being restricted, we have to limit our consumption for our future generations. So how we can do and how we can, take this limited quantity to a larger period of time is to be seen, and it is to be well augmented by we engineers. How to do? Let's see one by one. The basic definition of sustainability, as we see, it contains these 2-3 things. It contains future generation needs. It contains depletion of natural resources. And obviously, these 3 pillars of sustainability: economical, social, and environmental. All definition contains all this. And the crux of all this definition is to use our resources minimal or to the optimal levels. We should not just, because we are having it, so we have to use it. No, we have to see for our future also. Every time, whenever anybody speaks on sustainability, then these things do come, that yes, what we are leaving for our future generations and how much and how effectively. So these things has to be seen and has to be taken care for every infrastructure development, whether it being a construction, being a, development of whatever kind. So we have to see for these how we can save for our future generation with keeping in view of all the parameters what is desired for our construction. So, as I said, sustainability is key for future to prevent natural calamities. Yes, because so that the things do, take on for a longer period of time, we have to take care, we have to think on sustainability right from the day one, from the day go. Like what we said, that the growth, obviously, sustainability is linked to the growth. Growth is linked to all these 3 factors: social, economic, and environmental. So the judicious use of our natural resources will give us advantages in all these 3 pillars or all these 3 factors: social, economic, and environmental. Now, towards sustainability concrete, these 4 C's, what we say are important. Clinker, which is the main raw material for making cement, then cement itself, then the concrete, and all three are used in a direct or indirect way in construction. Then comes your aggregates, whether they are fine aggregates in the form of sand or coarse aggregate, what we say in terms of, the coarse aggregate as such, the major bulk of the concrete. And finally, the water. So sustainability, when we talk in terms of construction, in terms of concrete, these factors has to be taken into account. How we can save these all these resources when we build anything, when we construct anything, or when we even think of making in the developmental stage, think of making any good construction. When we take off the cement, if we see by 2050, India and China will be 50% of the global cement. And yes, for the cement, we need limestone, which is the main raw material for making the cement. And obviously the carbon dioxide, which is emitted during the process, and what the greenhouse gas emissions and all. I'm not touching carbon dioxide in my presentation because of the paucity of time. So, but yes, all those factors which is linked with this cement is again a dangerous issue, is an issue which has to be addressed in a big way. In the challenges of cement production, if we see, yes, the capacity production required has by 2050 will be more than the double what of the present capacity. And the current limestone reserves, as per the current capacity of the production of cement, will last only till 35 to 40 years. So we can see where we are heading to. And the energy requirement and the CO2 liberation, which are already interconnected with this cement production, we can think of that where at all it will lead to. Whenever we are seeing the carbon dioxide liberation, to give you a point, we always, the first ever industry what comes is the cement industry world over. The cement industry is being pointed because 8% of the carbon dioxide is liberated by cement industry alone. So we can think of at what kind of production level we are talking about, what kind of reserves we are talking about. But in the past, the initiatives what has been taken by the cement industry in the country is that, yes, the carbon dioxide emission has been reduced by 36% from 96 levels. Earlier, it was 950 plus tons per ton of cement production. Now it has come to 665 kg. And the share of the cement with reduced clinker content has increased to 75%. With the same strength levels, with the same properties what customer desires, the clinker has been reduced to 75%. With the reduced clinker, the cement share has gone up to 75%. Capacity of waste heat recovery system. If we see the cement production, a lot of heat is wasted during the production. So this heat which is wasted is put back into the system so as to reduce the energy consumption of the industry. So this has gone up to 550 megawatt, we can see. Average thermal substitution rate of fossil fuels, what we call is as alternative fuels, other than the coal, which is the primary raw material for, for this fuel. This has been, alternative fuels has been now started being used. Rubber tires and fossil fuels and all these kind of things has started being used. So 5%, if we are being able to, we are at the 5% level. And the things are still on the increasing trend for that. And reducing clinker factor. Obviously, when we make clinker, then we use limestone. And for the limestone, to reduce limestone, obviously the consumption of the clinker in cement production has to be reduced. So earlier it was only OPC cement, what we call as ordinary Portland cement, where we used to have 90% plus clinker. Now we have started making Portland Pozzolana cement and it is Portland slag cement. This third one is Portland slag cement, where the clinker has been reduced, as you can see by the pie chart, been reduced quite effectively. So what we have to see, the sustainability in our construction, 4 C's, clinker. Clinker is used in cement manufacturing, cement is used in concrete manufacturing, and hence the concrete is used in construction manufacturing, in construction. So these are all 4C related: aggregate, as I said, fine sand and coarse sand, and water. This sustainability is all interlinked in the construction through all these factors. This we can see that, yes, limestone reserves are only for next 35 to 40 years, what we have as per the project. Whereas the cement requirement is going to increase by more than the double as per the present pace by 2050. So we have to be very much careful in the usage of the raw material, the natural resources, what we have in the in all the stages of our construction practices. Carbon dioxide, as I told you, we have gone below till 665 kg per ton from 900, 950 plus. Then share of reduced clinker, cement with reduced clinker has gone to more than 75%. Waste heat recovery systems in cement manufacturing has gone up to 550 megawatts. And reducing clinker factor, yes, by using supplementary cementitious materials like fly ash and slag, which are generally considered as wastes in thermal power stations, power making industry, and steel industry, from where we get slag. They have been consumed and they have been reused in cement manufacturing, and they have been made as a useful products. And hence we have reduced the clinker from 90-95% to say 70-75% level. Depend in PPC, in pozolar fly ash based cements, and say up to 50% in slag cements. So as we know, we get fly ash from power industry, from thermal power industry, and where their fly ash quality of fly ash depends on the quality of coal what we burn, bituminous, subbituminous, or lignite. As we can see, the subbituminous coal, which is in the middle, the column middle, that gives us the best kind of fly ash, where we need SiO2, what we call as reactive silica, and calcium oxide. So these two factors, what we get is the best in subbituminous coal. So we try to use this coal as far as possible, but where we cannot, we use other coal, and we try to, redefine our manufacturing process or quality process through these fly ash also, keeping the cement quality as same. This is the kind of fly ash what we use. You can see how small the figures are, how small the particles are, and it's an X-ray, XRD magnification up to 2000 times, what we can see the figure. Similarly, GGBS, what we say is ground granulated blast furnace slag, which we get from steel industry. Okay, so here also it is having high calcium oxide levels, and that's why the replacement level of clinker is more in slag than in fly ash. So wherever the slag is used, we can replace the clinker, and hence the usage of limestone can be reduced up to by 50%. But challenges in with this fly ash and GGBS is that yes, the variability is from source to source, or even within the source, because the way we process, the way we collect the fly ash or the slag, there is a large variation. And the variability is because of the variation in the raw material which is being used in making this fly ash or the slag. So that's how the variability comes. And the second is the reactivity. The reactivity factor, what we say, as I told you in the previous slide, the reactive silica, what we have, is the most important factor in the usage in making the cement, and hence the concrete, more sustainable, more durable. So these kind of variabilities what we get is due to the variability of the raw material which is consumed in making these. Further to the blended cement, what we say, Portland pozzolana cement, where we use fly ash, Portland slag cement, where you use slag up to 50%, 50, 60% in cement. The further research is going on these LC3 cement. LC3 is lime calcined clay cement. So where even this clinker factor will be further reduced to say 35 to 40%. So from 50% in slag, from 75% in fly ash, PPC cement, this clinker factor can be further reduced to 35 to 40% level. So still the research is going on. Few countries have started accepting and producing this LC3 cement. But yes, India still the things are going on through IIT Madras and IIT Delhi. And second is this geopolymer cement, where even the clinker can be completely taken out. So this geopolymer cement is still, yes, it's in an advanced stage. Few places, I think it has also already been used. So these kind of researches are going on to make a sustainable cement and hence a sustainable concrete. When we talk about concrete, yes, the consumption is around 2 tons is produced for every human being. Obviously, it has been told that it is the second most material after water which has been consumed on Mother Earth. And every year, if we see, the concrete is produced equal to 1 kilometer by 1 kilometer into the height of Everest. Where does it goes? And how much raw material we can think of in producing cement, in producing these aggregates. We are consuming mines, and then the water. Some few countries are without water also in Africa. And it is said that, yes, next world war can be for the water. So now these things are being so much consumed and without which we cannot live with. Without concrete, we cannot think of at the moment to find any suitable product which can replace concrete. So we have to be sustainable in our thinking from the day go. That is my main criteria for this. So effect of concrete on the sustainable concrete, as we see the 3 pillars. On the environmental impact, I don't see any positive impact of concrete. But the negative impact is, yes, 4 billion tons per annum it has been produced. 8% CO2 of the total CO2 has been produced through the cement manufacturing, which is consumed by the concrete. And concrete usage estimates varies between around 30 billion tons of concrete is being consumed per annum. So we can think of resource depletion is going on from the day one. When we talk about the economic impact, construction provides employment and it increases year-on-year basis. But the negative impact is, yes, we have less durable and cost-cutting results in bad quality of concrete. When we talk about social impact, most versatile and affordable material and strong for all usage, but negative is booming in concrete jungles, yes, and quality of concrete is not assured. So the sustainability is like this. The next thing I want to, yes, the recycled aggregates. Recycled aggregates, we should, stress on the recycled aggregates, but it has its own advantages and disadvantages. But as far as possible, we should use about this. We should go in with the high packing density of aggregates so that the cement consumption reduces. If you see, if you see the clinker, yes, in concrete, it is hardly 10%, but the carbon footprint is more than 90%. So we can see that. When we talk about water, we can reduce mixing water, we can reduce curing water. Yes, there are effective mechanisms, as I have listed. There are more mechanisms than that, but yes, we should reduce the water also. And there is something called carbon curing also, which we can further see. Finally, what we can see is the construction. Today, earlier we used to go with the, only the strength of the concrete, but now the performance-based design has started. So the performance, how long the concrete will last, the design has started accordingly. Sustainability is what we should go with the less 3C, clinker, cement, and concrete. And hence, these 3 can be introduced in our construction. Less concrete, obviously, by high strength concretes and by using sustainable materials, we can reduce the concrete levels also. Less water and aggregates, increase productivity and efficiency. We can go, okay? And then negative emission technologies we can introduce so that the CO2 emissions is reduced. As we have Finally, reduce cement, reuse wastages like fly ash and slag, and recycle aggregates.
Thank you, Mr. Suneet, for the
Thank you.
detailed talk on towards sustainable concrete.